So how do we do the if statement that has an AND condition in it? So let's look at this one. We have x is greater than y and x is less than 0. So we have two conditions here, and then we have a statement. So if we do the original flowchart, we have, first of all, before that, we know that how ANDs work. If for this one to be true, for a series of AND a statement to be true, all the conditions should be true, right? So if you have, for example, here, okay, if you have like A, there is not a brush. If you have A and B and C, so let's say these are different conditions or statements. For this whole statement to be true, you need to have A to be true and B to be true and C to be true. So all of this should be true for the whole thing to be true. If one of them is false, you're done. You're not gonna basically run this if statement here. However, if you had or, so if you had A or B or C, and that's the symbol for or, if any of them is true, you are good to go to your condition. So that's also how the assembler works, and we are always like looking the direction like that. So you start from here. If this is true, you're gonna check the next one because you have to verify all of them are true. But if it was false, you're not even gonna to check the next one because basically the like this is already false, so you can never, even if all of these are true, you're not going to basically run this line of code. But in the or, as soon as you get to one of them that is correct, you're gonna run this statement. So that's a difference between and or. So here we have an and we have two conditions. So how are we gonna do that? We are checking at the first one. We are looking x is greater than y, same as we have here. If it's true, we are going to check the next one. X is less than 0. And then if that is true also, we are setting 23 to flag. If either of these are false, we are just basically exiting. So that's one, that's kind of like the original flowchart. On the other hand, if we are looking at this one, this is basically the modified version, which is equivalent to this one. And why again? Because here we have yes or trues in our straight line, which is going to be like the statement that we are executing, right? So, and we said again, in MIPS, we don't want to do that because we are only jumping. So this is not a jump, right? We are going to the next one. But in MIPS, we are jumping if it's a yes. So we want the yes to be here to basically to going somewhere else. And that's the way we're going to organize it. So in order to achieve that, we are basically switching these yes and no's, or true and false, and we are negating our statement. And also note here that x greater than y, the negation of that is x less or equal to y. So that equal also is important because the greater than doesn't cover that y here. And then if you have x is less than 0, the negation of that gonna be x greater or equal to 0. So there is the equal sign also there. But basically after switching these, you can switch the yes and no's here, and this is the modified version that we get. And you can try like putting numbers and actually try to see if it's make to make sense of it. You can try different numbers and see if you can actually get the same result, which you will. But it's good. It's a good practice to try. So here is the translated code that you see is S0, S1. We have X and Y, and that's the only two things that we have in our statements. And how we are doing it, we are checking branch less or equal, so exactly the same thing that we have here. And then we have our to statement. The order is important here. And if this is true, so we are looking at this yes, and we are jumping to the basically after the statement. So we are putting an exit label here. You can put a different label, that doesn't matter. So we are going basically there. And then if it's true, we are jumping, so we are going to, if this is false, we are going to the next line. So which is going to happen here? because if this is false, it's gonna go there. If it's true, it's gonna jump there, right? Same thing here. If this is true, we're gonna jump to exit, which is our yes condition here. And if this is false, which is this no, we're gonna go to our add statement. And we are doing with 0, so it's basically equal. And see that we have the branch greater or equal, which is same thing that we have here. So we are not using these original ones, we are using the modified version. And that's basically the story for the AND statements that we have. Now let's look at the OR conditions. So we already talked about how the OR conditions are organized. As soon as you get to one valid condition or one valid statement, like one that is true, you are jumping to this, right? So you are done. As soon as you get to a false, like as long as you're getting false, you are still going to the next condition and check, because you just need one true, basically. So here we have a is not equal to 0, so that's our statement. If that is true, as we said, it's good enough for our statement. So if this is true, we are going to our statement here. So if it is a yes, we are jumping there. So far so good. If it's false, we are going to the next one. So the yes is here, the no is here. And then here we have b less than 10. If this is a false, what's going to happen? At this point, we already know that the other one is a false. So that means it's false and false. So we don't have any true. So we're not going to run this. So if this is false, then we are exiting. However, if this is true, we are going to the next one and running this grade is equal to -1. So that's our statement. So what's happening here? The first one looks good because we have the no in a direct line is on our main path of execution. Basically, there is no jumps, and the yes, there is jump. But here is the opposite. There is jump on the no and no jump on the yes. So we want to flip this one. So when we flip these, we have to negate the statement that we have, and b less than 10 is going to convert to b greater or equal than 10. So at this point, it's good to just check the logic one more time, but basically you are good to go to convert it to MIPS code. So if you look at this one, branch not equal is basically this one, and we are jumping, if that is true, to the statement. So we have this label, you can use any label in if. So that is our statement that we have, and if that is true, we are basically going there, if it's true. If it's false, we are just going to the next one. Same thing that is happening here. Then we are checking this one. This time, if this is true, we are jumping out. We are not going to the statement. So the label that we have is different, is exit. And if that is true, we are going to the exit. If this is false, it's going to the add. And the labels are basically ignored when it's running on the statement. So they are not statements. So the statement after this one going to be here. And basically that's how you do the OR statement. And in general, if you have 3 or more, it kind of follow the same pattern. So mostly you're gonna keep all of them the same except the last one. But always you can draw this flowchart and basically convert them to understand what's going on.